Warning: this video contains clips and excerpts of a humorous nature not normally found in math class. These are intended to fight the adolescent condition known as short attention span, found heavily in the modern teen, especially when in school. The only thing you should attempt at home is the math. The rest, you just laugh at.
Hi, welcome back to AT Math. Today, 7.3, multiplication properties of exponents. Why, more fun than the car scare prank. Alright, now we've mastered exponents yesterday, but we're going to now do this. You have 3 to the second power times 3 to the third power. Basically, we're multiplying powers. Now let's remind ourselves of what this means. Basically, 3 squared means 2 3s, and 3 cubed means 3 3s. So I have 2 3s and 3 3s. Since they're all being times anyway, I can simply combine them. So I'll combine them to 5 3s, or 3 to the 5th power, as you will see here. And a shortcut would be, well, if the bases are the same, if they're both 3 in the bottom, then just add the 2 and the 3 together to make 5. A rule you want to write down is when you are multiplying powers that have the same base, you can simply add the exponents. You try. Go ahead. Let's see how you did. Hopefully you had the following: 7 to the second times 7 to the third, 7 to the fifth. This becomes 2 to the 17th. Hope you had it. By the way, this only works if the base is the same. For instance, here, 4 squared times 7 cubed, since the 4 and 7 are different bases, they just stay the same. I can't combine them. Now take a look at this. 2 to the 12th power times 2 to the negative 5th power. Both bases are 2, but I'm adding. Well, 12 plus negative 5 is actually 7. Now why is that? Basically, if you had 12 2's on the top, so just imagine these are all 12 2's, and 2 to the negative 5th means 5 2's in the bottom. 5 of these would cancel, taking these out, and leave 7 2's left, which is why you get that. This also works for more than 2 terms. Take a look here. 2 to the 12th, 2 to the 5th, 2 to the 2nd, 2 to the 3rd. All the bottoms are 2, so add across. 22 total for the tops, so 2 to the 22nd. 2 to the 12th, 2 to the 5th, 2 to the negative 2nd, 2 to the negative 3rd. Same thing, add across. 12 plus 5 minus 2 minus 3 makes 12, so 2 to the 12th. You try. 5 to the negative 2nd times 5 to the negative 3rd times 5 to the 21st times 5 to the negative 3rd. Go ahead. I wonder if you had this. Let's see, negative 2, negative 3, negative 3 makes negative 8. 21 minus 8 is 13. So 5 to the 13th power. Let's go ahead and take a break. And we're back. So what if you have 2 different bases, like 4 to the second times 7 to the third times 4 to the second times 7 to the third? Now in this case we can combine the same bottoms at least. So we can combine 4 squared and 4 squared to make 4 to the 4th. And 7 cubed times 7 cubed to make 7 to the 6th. Notice here how I went ahead and put them together, because I can shift them around because they're all times anyway. And I shifted the 7's over here. Then I simply combine the 4's into 4 to the 4th, combine the 7's into 7 to the 6th. You try. Go ahead. Let's see how you did. Hopefully you combine the 9's, you combine the 7's to get 9 to the 5th times 7 to the 5th. And by the way, this works if the base is not in a number as well. In other words, if you have x squared times x cubed, okay, you have 2 x's and 3 more x's, so you have 5 x's total. It doesn't even have to be a letter. 2 smiley faces times 3 smiley faces is going to be 5 smiley faces. Smiley face to the 5th power. You try. I think the answer I'm going to get is fish to the 5th times smiley face squared. Now if you're confused, you would know what I'm talking about if you were in my class. We change variables all the time. Okay, now this. 3 times 10 to the 3rd times 2 times 10 to the 5th. All we have to do is times the numbers first. 3 and 2, which you'll notice makes 6. 10 to the third times 10 to the fifth make 10 to the eighth. Now, because the sixth is between a 1 and a 10.0, 1.0 and 10.0, it's within the scientific notation limit, so I don't have to adjust this. So this is the answer as you see it. By the way, I can prove this by saying 3 times 10 to the third is going to make 3,000, and 2 times 10 to the fifth is going to make 200,000. And if I times them up with a real big calculator, I'd get 600 million. And the same, by the way, is 6 times 1, 2, 3, 4, 5, 6, 7, 8, it looks like. 6 times 10 to the eighth, which is what I had up here. You try. 3 times 10 to the 12th. Well, guess I showed you. Whoops. 3 times 3 is 9. 10 to the 12th times 10 to the negative second is 10 to the 10th. There you go. Quick break, and we're back. Now, take this here. 6 times 10 to the third times 4 times 10 squared. 6 times 4 is 24. We'll leave that for now. 10 to the third times 10 to the second is 10 to the fifth. Because 24 is beyond 10.0, we're going to go ahead and take 24 and divide by 10 to make it 2.4. But if I'm taking times 10 away from here, I've got to add it over here. So in other words, I'll go ahead and take 24 and make 2.4, but I'll make 10 to the fifth into 10 to the sixth. So I'm balancing. Times 10, divide by 10. Do it to one, do it to the other, but because they're on the same side, you have to have balance. There you have that. So 2.4 times 10 to the sixth. Again, one more to make sure we get it. Take this guy here. 9 times 8 is 72. 10 to the sixth times 10 to the 13th, 10 to the 19th. But 72 is beyond the 10 number, so I'm going to divide it by 10 to make it 7.2 and carry the 1 over here for the tens. You try again. Go ahead. Hopefully you got this. 4 times 5 is 20. 4 tens and 3 tens make 7 tens. Beyond 10, so I'm going to divide 10 here and add the 10 here. 2.0 times 10 to the 8th. This also, by the way, works in reverse. If you have 0.4 times 10 to the 4th times 0.5 times 10 to the 3rd. 0.4 times 0.5. 0.4 times 0.5 makes 0.2. 4 tens and 3 tens make 7 tens. However, I need between 1 and 10.0 or 1 and 9.99, whichever way you want to look at it. Either way, 0.2's got to be risen by times 10. So I can go ahead and times it by 10, but I have to take 10 away from that 7. So in other words, I'm not going to have 7 tens, I'm only going to have 6 tens. So 0.2 becomes 2.0. That's fine. And then I'm going to make 10 to the 6th. I leave a lot of extra explanations here. I think it might be a little too much, but basically all I was saying was 0.2. If I took 2 times 0.1, in other words, 2.0 times 10 to the negative first, because I'm borrowing against the 0.2. So I make it 2.0, but it's got now 10 to the negative first. Or I could just say, well, I'm moving over one space, 2.0 times 10 to the negative first. And I simply times them together like this. I said 2.0 times 10 to the first times 10 to the 7th. 7 minus 1 basically is 6, but I really think that's overthinking it. When you just come up here, just go ahead. If you times by 10, you got to borrow. If you have to take away 1, you get to add it here. So if you're going to add 1, you have to take away 1. If you take away 1, you got to add 1. Vice versa. I think it's easier. And with that, let's take a quick break.
If you don't go behind you, you can lose control. Whoops! Oh no! Oh, and it was a good run.
Alright, so simply 0.2 times 10 to the 7th, I move this over, 2.0, I go ahead and make this into 6th. Well, I guess I went ahead and explained that the first time, but that's okay. You try, go ahead. Go ahead. Let's see what you got. 0.2 times 0.4 is 0.08. And 14 tens and 13 tens make 27 tens, but I'll move it over 2 spaces to get between the 1 and 9.9999. So if I'm going to times by 2 here, I got to take 2 away from here. So 8.0 times 10 to the 25th. Just so you know, 3.5 times 10 to the 4th times 600 just turn 600 into a scientific notation, which would be 6.0 times 10 squared. And then 3.5 times 6, which is 21. 4 tens and 2 tens make 6 tens. Borrow against this 10, add it over here. 2.1 times 10 to the 7th. You try. Alright, I changed this probably into 7.0 times 10 to the third, I'm guessing, yep. 4.2 times 7, I'm going to guess 29.4. Right. And 4 tenths and 3 tenths make 7 tenths. I'm going to borrow 10 here, add it over here. It's 2.94 times 10 to the 8th. Since you're AT, go ahead and try the following. I guess I put this down here for you. That's fine. So 3.7 times 10 to the negative 4th times these two up. Combine these two tens. Notice how I get 15.54 times 10 to the negative second, but I'm going to go ahead and borrow. Borrow from here and add it to here, so it becomes 1.554. But negative 2 plus 1 is only negative 1. So notice how this is your finished answer. Now the next thing. We know 4 to the third power is 4 times 4 times 4. Well, that's no big shocker. But now 4 to the third power squared means 4 to the third times 4 to the third. Well, all you got to do really is just add the 2 3's and make 6. But you can just do this. When you have an exponent of an exponent, you can just multiply the exponents. So 4 cubed squared just means 3 times 2 is 6. So just take 3 times 2 and make the 6. It's so easy. You try. Did you get it? 7 to the 12th. 4 to the 32nd. Works the same for this, by the way. 7 squared to the negative third just takes 2 times negative 3, which is negative 6. Good enough for now. And 2 times negative 5 times negative 3, these two times make positive 15. That's your finished product. Even this. 9 times 2 to the 0. Well, 2 times 0 makes 0. Anything to the 0 power is 1. Now this is the same when we have more than two terms. So if we have, okay, 4 squared times 4 to the first times 4 to the fourth times 4 to the negative fourth, I'm just combining basically 2 plus negative 1 plus 4 minus 4. Well, I'm going to get 1 when the whole thing's done, so 4 to the first equals 4. Same with the x variable, by the way. X to the 12th, x to the 11th, x squared, x to the 14th. Combine all these guys, and you're going to get, well, yep, so it makes negative 11 total. Okay. And this, 7 squared to the negative third times 7 to the negative 6. Combine these first to make negative 6. So it's negative 6 and another negative 6, which make negative 12. 7 to the negative 12. Now we introduce a coefficient to this. So you have, oh, you know, let's take a break real quick. Take a break. Alright. 2x to the third. So I want you to separate the 2 and the x cubed. We're going to put them in lanes, as you're going to see in a minute, because I want to do one thing at a time. In other words, 2 is not being cubed, x is being cubed. 2 is simply there. It's saying 2 of them. It's very important to know here that 2 is not to the third power. It's just along for the ride. So when you have this, there's a simple 3-step process to understand. You really ought to write this down. If you do, this will be very easy. And those are the following. Number 1, determine if the multiplication will become positive or negative. In other words, here you have a positive 2 and a positive 5. Well, two positives make a positive. So the answer is going to be a positive. Then you multiply the coefficients. Well, okay, 2 times 5 is 10. Alright, well, I have 10 right here. Then I have 3 x's and 2 more x's. So I have 3 and 2 more, which make 5 x's. So now I have x to the 5th. So basically, just what I said. Positive makes positive. 2 times 5 is 10. You add up the x's. 3 x's and 2 x's make x to the 5th. So your actual answer should be, let's see here, 10x to the 5th. There you have that. Again, if you notice the system here, positive and positive. Now, I'm not talking about the exponent. I'm just talking about the coefficients. Positive and positive makes a positive. 7 times 2 is 14. 3x's minus 1x, because 3 plus negative 1 is 2. Time for some U-tries. Go ahead. Let's see what you did. Negative 42x to the second power, because negative 7 times 6, and 4x's and negative 2 make 2. Just as 6x times 6x equals 6x squared. Remember when you see this, now this time the 3 is inside the parentheses. That means everything inside here will get squared. So now it is going to be 3 squared, and it will be y squared. So 3 squared is 9. Y squared just becomes y squared. Just sits there. Another of that, Notice how negative 5 is inside the square. Square says everything, parentheses says everything inside here will be get squared, because square is right over here. So negative 5 squared, negative 5 times negative 5 is 25. Y squared is y squared. Try again. Go ahead. 3y cubed means 3y, 3 times 3 times 3, y times y times y. Now you might say, wait a minute, could I just take 3y times 3y times 3y? Yes, you can. It doesn't matter which way you do it, they'll both make the same thing. And here, negative 8 squared and y squared. Notice here I have 27y cubed, which is right, and this is 64y squared, which is right. Quick break.
There's plastic wrap on the door, and my cat's about to run through it. Go!
I made money on my thing.
And back. In this case here, you do the inside first. The negative must wait its turn. So 8 gets squared first to 64, and y becomes squared to y squared. Then the negative waits and makes it a negative. The negative is not being squared in this case. It has to wait its turn after the squaring work's been done. So we leave this alone. We square this. Okay. Combine them all. Negative 64 y squared. You try. Go ahead. Let's see how you got. This was to the 4th power, so 2 to the 4th power, s to the 4th power. Negative has to wait its turn, just like that. This guy up here, 9 has to square, j has to square, negative has to wait its turn. Combines just like that. Now, here you have, and I'm not sure what this 2 is hanging out here for. Get out here, 2. 2 to the s to the squared, s squared, j cubed to the 4th power. All this will become to the 4th power. Not as hard as it looks. Ignore this for a minute and just take s2 to the 4th power. So 2 times 4 is 8. And j cubed times 4, 3 times 4 is 12. So really it just becomes s to the 8th, j to the 12th. No biggie. Give her a try. 2d squared, b cubed, x to the 4th, rainbow cubed. All of that cubed. I hope you got this. I hope you got 2. Don't forget to cube the 2 though, because inside the parentheses. 2 times 2 times 2, well that's 8. D squared times 3, 2 times 3 is 6, so I get d to the 6th. B cubed times 3, 3 times 3 is 9, so b to the 9th. X 4th cubed, so that makes x 12th. And rainbow cubed is rainbow. That's a pretty rainbow, I know. Rainbow to the 9th. Try again, please. Oops, I guess I showed you the answer. Now try again. Alright, hopefully you got the following. Negative 2 cubed is negative 8. X squared cubed is x to the 6th. R cubed cubes are to the 9th. Lightning bolt to the 4th power cubed is lightning bolt 12. And Viking cubed is Viking to the 9th power, which is a lot of pillaging. Another, as you see here, x to the negative 2nd cube makes negative 6. 0 times anything is still going to be 0 though, so y to the 0 power, which you can just eliminate that because it comes to 1, and 1 to the 10 times anything is just whatever it is. So in other words, this here, this guy, this just becomes a 1, and that goes away. So really anything times 1 is 1, so this times 1 becomes that. Finally, the question is, in which form is the expression finished? How should we put the answer on the homework? There are 6 rules. These rules must be abided by. There are no negative exponents remaining. So if you have x to the negative 2nd, now we have to convert to a positive exponent. How? If it's negative, just flip. So instead of x squared, it's 1 over. Instead of x over negative square, flip it 1 over x squared. The same base does not appear more than once in a product or quotient. In other words, I can't keep it as x to the 5th, x to the 3rd. They have to fight it out. 5 versus 3. 5 wins by 2. So x squared goes on top. No powers are raised to powers. In other words, I can't have as a finished product 7 squared cubed. I have to go ahead and take 2 times 3, resolve it to make 7 to the 6th power. No products are raised to powers. In other words, I can't keep it like this. I can keep x squared, that's true, because I don't know what x is, but I can't keep 5 squared. 5 squared has to become 25. No quotients are raised to powers. X cubed or s cubed is fine. However, I don't want to keep it like this. I don't want to keep x over s cubed. I want to resolve that quotient. And remember, quotient just means a fraction. So in other words, they want you to go ahead and get rid of the outside parentheses and stick them in like this. And finally, numerical coefficients in a quotient do not have any common factor other than 1. So here, if you notice, 5 over 2 is okay, and the a and b can't mix. But here I could have divided both these by 2 to get this, and that's why this is finished and this isn't. In fact, if you want, you can even make this 2.5 a squared or b cubed, but I would take either. Both are super dandy to me. Finally, done, done, done. Thank you very much again. I'll talk to you later. Bye.
The dusty plains of southern India are the venue for one of nature's most astonishing hunts. It's an unusual face-off. In one corner, the cobra. Spectacled cobras can grow up to more than 7 feet in length. Their venom attacks the nerves, which can kill a human in as little as 30 minutes. Cobras are normally shy, but when threatened, they can become very aggressive, especially when a furry predator starts sniffing around. In the other corner, the mongoose. At first glance, this curious mammal may not look like much competition for a cobra. But the Indian gray mongoose is quite the predator itself, and its lightning-fast reflexes and thick hide have enabled it to add snakes like the cobra to its list of favored foods. The snake tries to warn the mongoose away, making use of that famous hood and raspy hiss. But the mongoose is persistent and on the hunt. When the mongoose moves into attack, the cobra strikes and misses. Again and again. Each time, the mongoose dances just out of reach. But when the mongoose attacks, he doesn't miss. Snake will be on the menu tonight. Rudyard Kipling would be proud.